Lesson 148, Compound Events. Welcome grade 6 to your final math video for the year. I'm sure you're happy about that. I'm also happy about that. I much prefer teaching math in person than through video, but I'm happy that we have made it work so far this way. So we're going to work on compound events today, which connects to some of the things we've been learning about probability. You'll notice that once again we skipped a lesson. That's because you need all sorts of different kinds of dice for that lesson that I have at school, but you don't have at home. So we're just going to skip over it and do an easier lesson for our last one. So compound events, which just means a combination of different events and their probabilities. So we're going to take the example from the textbook. The example was somebody was playing a game, and for this game they had to spin a spinner that had 3 colors, and they also had to toss a 4-sided die. And I looked up a picture for you so you'd know what that would look like. 4-sided, it's a pyramid, and then whatever comes up on the top, that's what your result is for that toss. Now, we've looked at finding the probability of these events when we talked about tree diagrams and sample space. So the first way we're going to look at for finding the probability of this compound event is using that tree diagram. So you could go ahead and write down all your 3 options for your spinner, red, blue, and yellow, and then branches out from there. That after that you can spin, or you could roll either a 1, 2, 3, or 4. So you can write down all of your options, and you would find that there are 12 total options. And here are the options listed for you. Now, we wanted to know the probability for spinning a red and then rolling a 3. And if you look in the list, you'll notice there's only one scenario where that happens, or only one outcome, to spin a red and then get a 3. So the probability of getting a red and then a 3 over here is 1 out of 12. There's only one outcome out of 12 total outcomes where that happens. Okay, so this is all review. We've done that before. That shouldn't be new. A second way to do it, which also is going to be a bit of review, is to use that fundamental counting principle. Now, what you could do is you can think of the spinner. There are 3 sections on it, equal sections, so there are 3 outcomes on the spinner. On the die, the 4-sided die, there are 4 outcomes. And if you think about the outcomes as categories, all you have to do is multiply them together to know that there will be 12 total options, okay? And there's only one favorable outcome of red and 3 out of 12. So the probability, you can just see it on the end of the screen there, is 1/12. You've come to the same answer using a bit of a different method. And method number 3, this is the one that you will probably use the most in your exercises today. I find it the most useful for these compound events, is simply to multiply the probabilities of the favorable outcomes. All right, so the probability of rolling a 3 on your die is 1 in 4. There's one number 3 option out of 4 total options. The probability of spinning a red is 1 in 3, 1 out of 3. All right, because there's one red section out of 3 total sections. And what you can actually just do is do some fraction multiplication. This really connects to that fundamental counting principle. You multiply these together, and you automatically get the probability of your compound event, right? 1 times 1 is 1, 4 times 3 is 12. You get 1/12 as your final probability. So you just take the probability of each event and then multiply them together to get the probability of them happening both, or of them both happening. And this works for other scenarios too. So if you wanted to know the probability of rolling a 6 twice in a row, now with a regular die, not one of those 4-sided ones, now we're back to 6-sided, you could sit there and draw a tree diagram. So you could go, 1, 2, 3, 4, 5, 6, and then, you'd have 6 branches splitting off of each one to figure out your probability. That would take you not a ton of time, but it would take you a lot more time than simply multiplying the probabilities. So we're going to erase that. And instead, oops, low battery, I better hurry up. Talk fast, Miss Nyhoff. So instead what you can do is you can take the probabilities of rolling a 6. Now, there are 6 sides on a die, and only one of them has a 6 on it. So your probability of rolling a 6 is 1 in 6. But now we want to know the probability of rolling a 6 twice in a row. So we have to multiply the probability of rolling a 6 again. And then you just do your fraction multiplication. 1 times 1 is 1. 6 times 6 is 36. The probability of rolling a 6 twice in a row is 1 in 36, or 1 out of 36. So a lot faster than drawing a tree diagram for this scenario. Let's do a few more examples. So let's say we had a scenario where the numbers 1 to 10 are in a hat, and you're going to be choosing numbers out of that hat. And each time you draw a number, you put it back in. Okay, so we're always going to have 10 numbers in the hat. So we can use this multiplying probabilities to figure out the probability of first drawing an even number, and then you put it back, and then on the second draw, drawing an odd number. So the probability of drawing an even number, there are 5 even numbers out of 10 in the numbers 1 through 10. So that's our first probability. For an odd number, the probability is also 5 out of 10. So to find the probability of drawing an even number and then an odd number, all we do is we multiply these. So we get 25 out of 100. Let's move below this hat over here, and that simplifies down to 1/4. You have a 1 in 4 chance of drawing an even number and then an odd number. You can also do it for if you wanted to see what's the probability of drawing specifically the number 4 and then an odd number. Well, the probability of drawing a number 4 is 1 in 10. There's only one number 4 in those 10 options. And then the probability of an odd number is 5 out of 10 again. So you just multiply those. We get 5 out of 100, which simplifies down to 1 out of 20. So the probability of drawing a 4 and then an odd number is 1 in 20. And you could also do that for just individual numbers. Maybe you wanted to know the probability of drawing a 4, a 6, and then a 1. Well, probability of getting a 4 is 1 in 10. Probability of 6 is 1 in 10. Probability of a 1 is 1 in 10. So your chance of that happening is only 1 in 1,000. All right, so just taking the probabilities of each individual event and then multiplying them together will get you the probability of the compound event, of those multiple events happening all in a row. So you're going to have to use what you learned with fraction multiplication, so hopefully you remember how to do that really well, and then you should be good to go. Let me know if you have any questions.